welcome all of you to the webinar today. In this webinar today, I will give you a getting started to the scripting features of UDE, and I'll show you how to use Python for automating debugging and testing. So the webinar is basically divided in three main topics. In the first few minutes, we will have a look at some of the principles that we need to know if you want to write scripts for the UDE debugger. And then I will switch to the tool and go through an example of a simple Python script step by step. And this script will test a application running on an AUX. And finally, we will have a look at the Python console in UDE that allows you to use also Python commands and scripts even in an interactive debugging session. Okay, then let's get started. The purpose why we do scripting in UDE is that we want to support automated debugging and testing. And that's the reason why we call this UDE automation. So it is typically the workflow that you control the debugger from outside by another software, or also from inside by another software. And for automating something or repeat everyday tasks. The automation feature is part of every UDE base license, and this is the first good news. You have no additional license fees to use the automation feature in UDE. The heart of the UDE automation is the so-called UDE object model, which is an open and flexible software API that provides access to all the debugger functions. The object model is based on the component object model from Microsoft. The short form is COM. This is a deeply integrated and widely used technology in the Windows world, and therefore a quasi standard when it comes to application communication or something like that. But you can also use this with many scripting in programming languages. And here comes the second good news. Because we rely on Microsoft COM, we benefit from these advantages, or from several advantages. We do not need, because COM can communicate with or many scripting languages can communicate with COM. We do not need a proprietary scripting language, nor we are bound to a specific one. That means you can use any scripting language you like. You can work with your existing knowledge and your preferred tools, and you don't need to learn a new syntax. The examples I'm showing today are based on Python, because Python is at the moment one of the most popular programming languages, and I think most of you are familiar with it. But all the concepts are also can be also used with other scripting languages. And last but not least, scripting is only one part of the possibilities to control UDE via the object model. And the object model is also the base technology for coupling third-party tools to UDE. So, for example, a test tool can use the object model to directly test on a real hardware using the debugger functions. For example, the test tool can control the target device, start the application, stop the application, setting breakpoints, getting access to variables, writing variables, reading variables, and so on. We will see it later. Okay, This is a picture that shows you a excerpt of the UDE object model. You can see the object model is composed out of a set of objects here. These objects provide interfaces that gives you access to almost all the debugger functions. As you can see, this is also a hierarchy here. If you need a specific functionality of a particular object, for example, of the debugger object of a core debugger in UDE, you have to start from top level, and then each object, each higher level object provides properties or functions to access the next lower object in that hierarchy. And then you can ask again and again for the next level, and so you get finally the object that you need with the functionality that you need. At the very top of this hierarchy, there are two objects here that are used as a starting point. The first one is the so-called UDE launcher object that is used if you want to create a new debugger instance. So basically to start UDE. And the other object is the UDE running instance manager, which is used if you already have an UDE session opened and you want to connect to that session. From these two top-level objects, you get the application object, and from there you can start to obtain all the other objects that you need for in your script or in your test application. Basically, the UDE application object is the actual root object in the debugger object model. And all the other objects below the application object and application object itself provide the real debugger functions. So you see only a few of the objects. The object model is contains much more than you can see here, but I have put only a excerpt here on this slide because of the space and that you can see it very clearly on the screen. All the debugger objects provide methods to or properties that you can get, which helps you to get the next level objects here in that hierarchy. And I'd like to show you how it works with that small script here written in Python. That small 4-liner retrieves the debugger object which is needed to start the application. And for that, we in the first line attach to a running instance of the UDE. So UDE is already opened. We use the running instance manager to get a UDE object. Then from that, we get the workspace, which contains all the necessary information that you needed in a debugger session. And from that workspace, we can get all the core debuggers. In that example, I like to have the core debugger for core 0. And once I have the core debugger for the core 0, then I can start with the go command the application. Each object implements methods and functions, as said before, and also provides some properties. This is the documentation for all the methods and properties of the debugger object. So you see on the left side all the functions that we provide, which are basically doing something. And on the right side, this is the documentation of all the properties, which basically getting or setting something in the target. The screenshots here are taken from our help system. So you see that the objects, functions, properties, and so on are well documented. And you can click on each line here on each blue text to get more information on how the definition of a specific function or property looks like. That is given in a more or less generic form. You get also a description text and also the explanation of the parameters. And finally, also some code examples that shows you how to use the specific function in your scripting language of your choice. And in our case, we are concentrate on the Python code. Okay, now with that knowledge in mind, we can switch to the example and start to write our first script. What we want to do is we want to write a test application or a test script that is testing a simple application. And the application to be tested is running on a Infineon Aurix, and it implements a simple clock. So the hours, minutes, and seconds are simply counted up. And we want to test one specific function, and this specific function is the wraparound when a minute is up. So we expect that the seconds are reset to 0 and the minutes are incremented by 1. That is the hardware setup that I'm using here on my desk. I use a UAD2 Pro from our Universal Access Device family, which is part of the debugger here. That UAD2 Pro is connected using the DAP interface to the triboard with the Aurix, and the UAD2 Pro is connected via USB to my PC. For the script development, I'm using the Anaconda Python distribution, which is not part of UDE. So you have to install it separately. And I'm using the Visual Studio Code editor for writing the script. For the Python distribution, you need the Pywin32 library as well. If not already installed, you need to install that using the Python mechanisms. This Pywin32 library provides all the necessary functions for using COM in Python. For writing the Python scripts in Visual Studio Code, you will need to install at least 2 more extensions, namely the Python extension and the Pylons extension, to get it work in Visual Studio Code, to have a nice syntax highlighting and some other Python features. And you need to set a Python interpreter into Visual Studio Code because Visual Studio Code itself does not contain an interpreter. You can use Visual Studio Code not only as a editor for writing code, you can also use it as a debugger. It provides some debugger functionality for Python, so it may be very helpful to use this tool also for scripting development. For the demo, I'd like to use another extension, the JupyThon Notebook. That extension in Visual Studio Code allows you to write Python scripts step by step and execute each step to see if it's working. And I think that is very helpful to understand what I'm doing right now. Okay, then let's switch to the UDE and also to the Python development here in Visual Studio Code. So on the left side, you see the UDE, which is empty, so no debugging session is running. On the left side, on the right side, we have the studio code, which is also empty right now. The first thing I'd like to show you is how to write a script that attaches to a running UDE session. For that, I load a workspace into UDE, which contains all things that you need for debugging, for interactive debugging, for example. So we load the target application into the flash memory. We see some code already, or some source code already loaded into the program windows. We have some variables in the watch window, which are the important variables for our clock that we want to test. And I'd like to show you also the function that we want to test, which is the update seconds function here in our code. So it's basically checks if we have the wraparound on the end of a minute. So we check for 59 seconds equal to the seconds variable, then the seconds are reset to 0 and the update minutes function is called, which basically increments the minutes and checks if a hour is over and then calls the update hour. But we are concentrate on the update seconds in our test case. Okay, then let's get started in writing the script here. The first thing is I create a new Python file. In that case, I use the Python notebook as mentioned before. So the notebook basically provides us cells which can be filled with code in Python, and each cell can be executed immediately, and you can check what happens here with your Python code. And so step by step, we want to create a complete test application or test script for our specific test here. Firstly, we need to import some of the libraries that we use. The most important one is the win32com.client library, which is part of the pywin32 library. And this with that functions, or this library provides us functions to get access to the Microsoft COM. With the access to Microsoft COM, we can then get access to the UDE running instance manager. We ask for the Microsoft COM environment for the UDE running instance manager, which is basically part of the Windows registry here. All the information are within the Windows registry, and we can get access to that specific service here. We need to execute these two cells here, and the second cell also checks if there is already a UDE available here. So we check if the count of the instances found by the running instance manager is not 0 here. Otherwise, we would get a failure. Okay, we executed both of the cells, and then we can attach to the application object of UDE, and for that the running instance manager has a get instance function, and we want to get the first UDE which was found. We have no others opened, but there may be several opened at the same time. So we execute that. To see that something has happened, I have printed out a UDE version, which is UDE 2023 at the moment. Okay, then once we have the application object, we need to get access to the workspace. You remember the picture that I have shown you that showed you the application or the hierarchy of the UD object. So the first object that we need is the workspace object, and the UD application object has a property that returns the workspace object, and to see that something has happened, we print out some information from the workspace, and we also check if we have a target device that is connected, and that's true. We have connected a AUX here, so we get the connected message here. Okay. Then we want to start the application. For that, we need the core debugger, which provides us the functions for control the target. For example, gives us access to a go function or a break function, and we ask the core debugger the workspace for the core debugger for the core 0. We have a multi-core system, so you can name it by the name or by the instance number, but the name is more user-friendly here. So we ask for the core 0 debugger. We get the core 0 debugger, and then finally we can start the application by the go function. Start the application, and now we see our application is running. The seconds and all the variables that we have in the watch window are counting up. So it is working right now. And then we want to test our update functions. A good idea is to set a breakpoint at the beginning, then to set some test vectors or a test vector, execute the update functions, set then a breakpoint to the end, and wait that the update function is finished, and then read the results and compare them to the expected values. To do so, we need breakpoints, for example. The breakpoints are also an object in UDE, and these are child objects of the core debugger, because breakpoints are correlated. So we get the breakpoints using the breakpoints property of the core debugger. We set the breakpoint at a certain location here. You can use, for example, the name of the function where the breakpoint should be set, or you can also use an address or a more complex breakpoint location string for that. You find the syntax in the help. And then we wait basically that the breakpoint is hit by this line, and if something is failed, then we leave the script with an error message. But I expect that this will work. So we set the breakpoint. You see the breakpoint is immediately hit. And then we can set our test vector using the write variable function of our core debugger. So we set the seconds to 59, which is basically right before the reverb round should occur. And I decided to set the minutes to 10, that we have a good starting point for our test. So I write the variables. You see it in the watch window. So we have 59 for the seconds and 10 for the minutes. But you can also check this by reading the variables using this Python script. We do so. So the core debugger has also read functions for variables, also for memory or for registers. But in this case, we read this with the read variable functions, and we save the minutes before, which is the current the current value of the minutes in a variable to use it later on. Okay, so seconds are 59. We have a readback of 59, and the minutes before a readback of 10. And with that, we can now continue the application and proceed to the end of the update seconds function. For that, I'd like to remove the breakpoints or the breakpoint and set the breakpoint at the end, another one. And here you have another possibility for this breakpoint syntax, which is the name of the function plus 8 lines. So with that code, you remove the breakpoint and set the breakpoint again at the end of the update function. And then we can proceed by doing a go again and check, of course, if we hit the breakpoint. I execute this code here, and you see the breakpoint, the function was executed and the breakpoint at the end was hit, and we can look already to the watch window. We see the seconds are reset to 0 and the minutes are now incremented to 11 incremented by 1 to 11. Okay, but we want to check this in the script because we do this at the end automatically. So we need to read the values for seconds and minutes by the already known read variable function of the core debugger. And then we do the check. We check if the seconds are 0 and the minutes after are the saved minutes before +1. And if we execute that, no surprise that the test has been passed. And at the end, we can clean up our script so that we remove all the breakpoints and start the application again, and it is running. And the final step should be, and that's important, a cleanup of all the used objects here from UDE. So we have to clean up the breakpoints, the core 0 core debugger object, the workspace object, the UDE object, as well as the running instance manager object that you have safely ended the script, and you can close the UDE at the end safely. Okay, then we execute that and then everything is fine. Now you can export, for example, this script in a file, in a Python script. I have already done this and have changed that script a little bit. I opened that file, which is that one, which is basically the code that we have written right now. The only thing I have changed is because we are used the Python Jupyter notebook. There are several comments here added showing which code belongs to specific cells, and I removed that here. And this script can now be debugged using the Visual Studio Code integrated debugger for Python in order to check if it is working, because within UDE we have no Python debugger at the moment, so we have to do this externally. For that, you can use this button here, debug Python file. Before I do that, I'd like to set a breakpoint here somewhere, let's say here on this position, or basically click on the border here, and you see the typical breakpoint icon here on the left side, and then I start stop the application, for example, set it back that we can see everything, and then we start debugging, debug this Python file. Then we see here on the left side some debugging windows opened, and we see we are hitting the breakpoint. We see all the available variables and available UDE objects, for example, the running instance manager, the core debugger. You see some information here about the core debugger. All that you will also find in our help system. And you can, of course, look at the variables at these two to the watch. You see these two are not valid at the moment because we have not executed the read variable function here. But if I single step, then you see the values after the test has been executed, and then I can step through the code as we did before, and it's the same functionality. So with that, you can write your script, you can debug your script, and create your own test script for your application. Okay, I want to go back to the script here. Close everything. Okay, and we want to change that script that way that we're not attaching to a running UDE, but we want to open a new one. So I close the UDE for that, and we change the script a little bit. To open or to create a new UDE debug session, we need the UDE launcher. I assume you remember the picture of the UDE object model, and the very top objects. We had the UDE running instance manager and the UDE launcher. And for creating a UDE from scratch, we need the launcher. That's why I changed the first lines here. We need the imports, of course. We have to execute this. But now we ask the COM subsystem and the COM library for the UDE launcher object, which is also registered in the Windows registry. We ask for the launcher, we got the launcher, and then we need some predefinitions, or I like to use some variables before to have them later in the code available. For example, a working directory which tells you where all the files are located. Then, of course, we need the workspace name or a workspace path for the workspace that we want to create when we open the new UDE session. And also we need a so-called target configuration file, which contains all the information about the target or the device that we want to connect. So in that case, we have a TC39 AURIX tri-board here. So this configuration file needs to be already present in that case. So I reuse that one what I used in the workspace before. With that code, we can now create our UDE session. That is not necessary anymore because we are not have a running instant. We can replace that code by this code. So we ask the launcher to start UDE and create a workspace. Start UDE. We start UDE exe. We tell them the workspace location and file name. We tell them which configuration file should be used, and that true means that we want to create a new workspace. Okay, I execute that. You see UDE is now opened, and we have an empty workspace. We have connected successfully to our device, and now we can get, as we did before the workspace object. Basically, I like to clear the outputs that we see that something new happened. We execute that, we get the workspace, which is now called launcher demo. That was the name I defined here in this line, in this definition line. Okay, then we can get, of course, the core debugger for the core 0 as we did before. But now we have we have no application loaded. So we need now to load the application. So I insert some new code here to load the application. The core debugger for core 0 provides us a load and flash function that loads a ELF file, which we have given with that line into the target system. If we execute that, you will see, okay, the ELF file is now loaded. You see the flash programming was executed, and some source code is now available here in the program windows of UDE. Okay, then it is quite the same. We can make a go here with the go command. We can add the breakpoint using the same code. You can write the variables here. I have no watch window open, so you will see nothing here at the moment, but we can check this with this read variable code piece of code. So seconds are now 59 minutes before is set to 10. So that is the same test vector as before. Then we remove the breakpoint, set the breakpoint at the end. We start the application again and hit the breakpoint at the end of the update seconds functions. We read the test results. We see the test has been passed. Everything is okay. We remove the breakpoint, start the application, and then at the end, we need to clean up everything. Here, the code needs to be changed a little bit because we want to firstly close the UDE. So this can be done with the stop instance function of the UDE launcher. And of course, we need to clean up also the launcher object and not the running instance manager object. And when we execute this, UDE is closed. Okay, so these are the two ways to write scripts, either to connect to a running UDE or to create a new UDE session from scratch by giving a workspace and a target configuration file and loading the application into the flash or into the RAM. It depends on the compiler settings of your application. Okay, then I coming to the last thing very quickly, the UDE Python console. Using the UDE Python console, you can use Python also from inside UDE. You can use all the Python UDE commands and as well as standard Python commands. The API is the same, so you can use all the things that I've shown you some minutes before, but there is a difference. Of course, some of the root objects are already existing, especially the UDE workspace object. And in the Python console, you have, of course, some nice features and functions that you can use it very conveniently and efficiently. For example, command history, auto-completion. You can save command sequences and run them again later on, and you can also execute complete scripts, for example, our test script. And I'd like to show you that right now. I open the UDE again, open my workspace from the beginning. I program the application into the Flash, and then I open from the Views menu, other windows, the Python script console. And in addition to that, the console that we see some outputs of our scripts within the UDE. And here from the console, I can, for example, use the same syntax as before. We can access the UDE workspace, which is basically already existing here. We have a nice auto-completion by using the Control right key. We can get the core debugger for the core 0. And then we can start, for example, the core 0 by the go command. Okay, or writing some variables. Write variable, for example, seconds to 0. Okay, we have seen seconds was reset to 0. Okay, and from that we can also open or run a script, and I have a little bit changed the script that we already created. You see the same functions here that we used to test our application right before. The differences are that we don't need to use either the launcher or the running instance manager. The workspace is already there, so we can start with the workspace and get the core debugger for the core 0. And then I have changed some of the print outputs here to a function that is also available by the core debugger to print out into the console of UDE. And at the end, of course, we don't need to clean up everything. The only things you need to clean up are the objects that you retrieved within your code here. And you can load this here and run this script. I have added some wait cycles here to that it's not too fast to see. So you see the outputs here in the console. The test has been passed, and then finally, the application is tested. And with that, a little bit over time, I want to close this webinar, and I'd like to thank you for your attention. If you have any questions, then please use the webinar panel or drop us an email. And as a short announcement, there will be a third webinar this autumn. This will be on November the 16th about debugging and runtime analysis of AutoSAR applications at the same time together with Hitex. Thank you very much.